And there's a scene at the bus stop, which we kind of created. And this previs was created after we'd done a kind of week-long recce in Zanzibar. So we had a really strong idea of the location that we wanted to shoot in. We took kind of reference photographs that we could kind of build really rough base templates for all the environments, or we could kind of camera project onto certain scenes and kind of quickly rig characters up to do certain movements. And you can see here just how, in some of the shots particularly, how similar they are to the final film. And we downloaded a rigged fish from TurboSquid, and we had some fun with that. And we linked kind of lots of mocap data to the fish and also to the kind of base characters that we were working with. And I'm going to be showing you how to kind of add mocap data to a basically rigged character, and how to blend different mocap data together on layers, and even add custom animation on top of the mocap data very, very easily. So this is where our character's kind of like contemplating setting out to sea to find the fish, and then he sees a splash in the water. And some of it was actually, some of the previs was actually filmed from the characters themselves in kind of like early kind of like tests and character tests. And here we see our kind of character setting out to sea in the previs with our rubbish, and the boat's kind of intersecting the water. And we did lots of different kind of versions of this. So we're not really caring too much about any kind of accuracy or consistency in visually, but we're trying to think mainly about camera and how it's working with this kind of story of the scene. So very easily we've just kind of linked that, and this is obviously going to be, if we invert our selection, we can see that it's actually happening. Let's leave this light. You know, it's all linked with our main character, but obviously we don't want to really work in this mode because we can't see the movement very well. This is where we'll actually start to you know, export the viewport. Drag this back over. We'll actually start to grab our viewport to see this properly, but for now we don't really need to do this. We're not finished with our data set yet. So we can work much faster by working with the bones here and see what the movement's actually doing. This is quite a long mocap set. So what else can we do here? If we go back into our motion panel, you have to click on one of our bones to see anything. Go back into our mixer, which is here. Let's just zoom out of this for a second. So what happens if we add a new track to this? We want to dance around for a second, and then we want to run off in a certain direction, say. So let's find another mocap set. Let's see what we should add here. Let's add a jog. And see what's happened automatically is, if we just stretch this in, automatically it's created a kind of link between these two files. When we move this, we can see that that link is editing as well. And what this is a blend between the two sets of mocap. It's automatically clipping our first set when we move our second jog motion we've added here. So let's see what happens when we kind of go to around about this timeline here, where the jog kicks in. Let's see what's happening to the actual biped. Again, it's quite a long frame set, so you can see here our timeline's kicking in here. And then we're seeing that he's stumbling around, and then he starts jogging. Let's increase our timeline. you can see here, that transition, he starts jogging there. And this has actually worked quite well. Normally it doesn't kind of blend quite as successfully as this, and normally to solve that, what you have to do is, within our kind of blend kind of clip here, we can edit all different kinds of parameters on how that blends. But while I'm doing that, I'll actually scrub along, and this is actually the full previs of the film, or one of the issues anyway, that we created. And it'll kind of give you a great sense of the different scenes and how we kind of set it up. Jeff, do we have sound at all? Might need to go louder. Oh, here we go. Yep. So this is Previs with motion blur, and it works really well. I remember when we did this, I was like, that looks really good. We should do more of that. But yeah, I'll let it play, and I just wanted to kind of stop on that one because it was such a revelation for us. We're mixing that with actual footage, obviously, as well. And the same technique with this one, as I've just showed you. Linking the camera target, following it manually, adding and blending different controllers, different mocap data sets. Even playing with depth of field. Just giving you a sense of how to tell the story. Doing that all at the previous stage. So at the beginning of the film, our two characters have stolen a camera from a tourist, and the tourist is chasing after them. Here we see all of the market scenes. And a lot of this is remarkably similar to the final film. So this one setup scene with the market, we did lots of different camera moves in and around, how they run past, following them, static cameras as they're kind of running past. So you're blending a running and a jumping motion. You can see where that transitions a little bit there, but it doesn't matter. It's doing exactly what we need it to. Using images and just really basic techniques, but it does exactly what you need it to.
Yeah, I say we build Buckingham Palace.
And then combining that with kind of
that's very essential.
Kind of dialogue tests and things like that. I won't show the whole thing because this is the full film in previs at this stage. But it's just good to see different scene setups, simple camera projection and backgrounds that are put in. Camera projection in the same way.
That is good thinking.
So I can kind of scrub through this, and we can see some of the different scenes that we set up. This is on the pier with a fish. As a fish jumps out of the water. So you can see that motion, that element here. Changed a little bit in the final film, that one. But then we get to the kind of transformation sequences. It'd be quite good to show some of these ones.
African herb, while in her home.
simple animated collages of the kind of beaches with the rubbish, using Mass Effects to drop rubbish into the sea. These bits actually we didn't stay in the film. It was slightly too ambitious for our underwater shoot to incorporate a lot of these elements. We had this quite ambitious shot which we had no idea how to film. Fish turning into signs. It's going to be a bit tricky, that one. Lots of different purposes, but for us it was this kind of magical transformation of our Zanzibar stone town. And then this is the final shot. So, first step in this process was obviously tracking. And there's a few things that we can set up. We're going to be talking about how we did all of these different things. So this is our kind of, this is our PF track window. So let's talk first about the kind of interface of this thing, because it can be quite alien to a lot of other softwares that we use, and it works very differently as well. Anything that's not attached to a kind of fixed point and that have a reference like this, where it could slip along that point, it's good to just check. He's kind of attached more to the hinge, so he's okay. And again, this center view is really great for kind of checking all your tracks. So again, you can see this one visibly slipping. And he's very short, he's a useless track. A lot of the ones on this gate are fine, because that's a fixed thing, it's quite contrasting. We can leave those in there. But again, anything that's kind of along in front of that and attached to it, we need to delete. All the ones on the left there are good. We have a moving, dancing one here, which we want to delete. Dancing one there. And again, when you're deleting all these tracks, it doesn't necessarily mean the solver is going to be any better, because you've got less data to work from. So it's that combination. He's rubbish. It's that combination of kind of good accuracy and amount. And if you haven't got enough once you've deleted, because you have to delete so many from a shot like this, when you've got a huge amount kind of covered by our characters and then lots of kind of intersecting surfaces, then you might not be left with enough tracks to actually, the camera to be able to understand that solve. So that's again where the manual trackers come in. Okay, we have another quick question in the room here, so we'll just get the mic.
I was just wondering when you the reason why you're not working with mask, because you don't want to redo the auto track again and allow it to refocus on the amount of points on the.
Redo the auto track? What? Sorry.
Yep, I thought the idea of using masks were that you would refine it like you're doing now, basically, but you would refine the mask instead, and this way you could redo the auto track.
This way you don't have to redo the auto track. The auto track, you've already created the auto track, and you're just deleting the points that are tracked. So it's a preference thing. You can either create a mask at the beginning and then auto track, and then it just doesn't take into account anything that's inside that mask or outside the mask. You can invert it. Or you can just track it and then just go through and delete the points like I've been doing. For me, well, for most of us in the studio, we prefer just manually going through and deleting things, just because it takes quite a long time. Actually, it looks really quick to actually just generate that mask and to track it in, but it can take some time to get that Bezier to be kind of tight enough around your character that you're not ignoring some good points, basically. Because I need every point I can get in a shot like this. I don't want to ignore points that are maybe good, because I know I'm going to be limited by a very few amount of points. So for me, the most detailed way of tracking this shot would be to delete all the points within the characters manually. And I know it's only like 200 frames or something like that, and I can do that, I think, in equal to, or if not faster than creating that mask. And I think the results are more accurate because you're deleting very specific points, basically. It's a preference, you can do it either way. Some people create really complex roto masks and then import those and then have that separately. But for this, it was just as easy to kind of delete the points, basically. So, but you don't have to retrack now that you've deleted those points. You just have to resolve the camera point, and that's how you get the camera to be more and more accurate. Is to keep going back, altering the auto track, adding manual trackers, and then resolving the camera. Does that answer your question? So let's just have a look if there's any other points that we are struggling with. And we can see visibly. And then we'll do another solve and see if that's changed anything. Again, we might get unexpected results because we are deleting a lot of trackers here. So we might not have enough data to generate our solve properly. I mean, this one's, what is this actually tracking? Nothing. Yeah. So it is a very fine comb operation when you're kind of dealing with tracking markers and points, but the results kind of speak for themselves when you do spend enough time on things. And the thing is with tracking, it's either right or it's wrong. It's not kind of right. As soon as your kind of model slips, you've lost that illusion that you're trying to create when you add digital elements to real footage. You have to keep the audience completely. Just to drag this guy in. And then you can just select a random amount of objects in your viewport. And then we can just literally play with kind of like these keys so that we're moving and offsetting the animation. What we might need to do, however, is select the slice and make it unique, because otherwise we're only making the offset of the rotation of the object unique. We're not actually making the slice rotation technique unique. So we can keep the object as an instance, but not the actual slice modifier. Let's move these guys, the ones we had selected, back. Random select. And then we can move things a bit more. And we did this for a few things. We did this for the rubbish scene in Jonah, where all the rubbish kind of piles on the beach. And what we used it for there was kind of to random select all of the rubbish and then offset the transparency of the rubbish so that it was kind of appearing. It kind of had a dappled effect to the appearance of it, and that meant that. It was kind of like flickering in almost. So if we go to the object properties, for that purpose, we animated the visibility from 0 to 1 over 1 keyframe for all of the rubbish, and then selected random select for however many objects were in the scene, 20%, 10%, whatever, and then kept doing that until we had a very natural kind of flickering effect appearing. So we can kind of keep going with this and offsetting things subtly to create quite cool animated effects. Now, to kind of make this simulation a little bit better, I mean, we have a few things kind of popping around. It's not too bad, but if we wanted to kind of like make this slightly more accurate so that objects are colliding a bit more accurate, or they kind of come to a stop a little bit sooner, the settings within the physics system kind of add to that. And this is similar-ish to how physics works on its own, or Mass Effects works on its own. So we can change our collision tolerance. This will basically say between materials how close their kind of RayFire mesh that it kind of puts around it allows them to kind of collide. So this is on 0.1 of a meter. Maybe we want to put this on 0.001, and that's going to be much more accurate. Might take a little bit longer to simulate. And then our sub-steps, again, this kind of setting is really dependent on what is happening or wrong with your scene. So sometimes 3 works fine. Sometimes you want to up this. And essentially what this is doing is how many times RayFire is calculating your meshes between frames. So between frames 0 and 1, it's going to calculate 3 times. And we can kind of up this to, say, 7. You don't want to go much above 10 for these things. And sometimes the higher you go, actually, it doesn't give you better results as you might think, because it's kind of overthinking each kind of calculation. And sometimes you just need a simple effect. So if we unbake this, and we also change our, because we've got 2 depth levels, we can change the probability of that second smash. So we can change that to 30% probability. So that was done in a simple cloth sim, constraining points to the base mesh, and then creating nodes within the cloth sim to attach vertices of this mesh into onto those points, basically. So you're constraining the points to the mesh, and then you're constraining the vertices of the poster to those points. And then with the wind effect, you create quite a realistic mesh, which is kind of taut. So I'm going to save this, and then I'm going to open up a few other files, which is using, again, 2 other kind of particle systems within Max. One is a kind of feature which is now built into Max. It used to be a plugin called Box 2 and 3, which is a PFlow plugins. But now in 2014, it's kind of part of the base settings within PFlow. Deflectors are kind of offset in their animation. So we can see here that the keyframes down here that are offset by, I think, about 5 or 10 frames on each one, so that the collision test operator only starts when that deflector goes through that system. And by offsetting it, you can create this quite dynamic kind of like appearance of this kind of girl sign here, which we did. And we've used this since in other applications as well, because again, once the kind of initial R&D was done on creating this this system, then it's very easy to kind of replicate and swap out, because we have different objects attached within each of these data sets, but everything else is more or less exactly the same. So again, I think with this one, it would have taken too long to do this live in the class, but the benefit of this is that we're giving this away within the set, so you can actually go with this file, pick apart what everything is doing, and you can kind of understand it for yourself and try and understand what the scale and the keep apart and the go to rotation, what their purpose is for each thing. So again, once you kind of get a bit more familiar with some of the aspects of PFlow here, then it will be a lot more obvious of what's going on, and it's actually not that complicated. So what I also want to show you is a really cool effect that we used in the Golden Age film. I wanted to illustrate how it kind of can be combined with Frost and introducing you to Frost very quickly. So let's unhide our, or let's just add our frost node in, another one. We've hidden our other one. So as soon as we click on frost up here, it's going to mesh automatically what we've got attached to it, and that'll be we can add PFlow, we can add thinking particles, and we can even add real flow meshes and things like that. And the way we use frost mainly is either for meshing particles like this that we want to have completely in control in Max, or the way we've done it is when we've done a real flow sim and we've kind of generated our base mesh, our splash and foam particles separately, and we want to mesh them slightly differently, and we want to have that control within 3D Max rather than having to stick with what we export from RealFlow. So this gives us a huge amount of control, and when you're doing kind of splash and foam on base meshes, you normally kind of work with different materials in each set. So you'll have the base mesh as kind of a water material, you'll have the kind of splash and foam as a slightly more opaque white material, and that will give you a kind of the kind of splash and foam effect when you're rendering. So anyway, we've got lots of settings we can kind of mess about in here. So we can kind of add more particle effects. With here we can see our thinking particles is linked here. We can change the way that the object is meshing by going to the meshing parameters and changing this to geometry. We can change this to be any kind of object we want, but it's currently set to plane. We can custom pick our own geometry. We can select box. So we have a kind of a particle emitting a box, which could be quite a cool effect. We can do so much with simple meshing parameters within Frost. Let's have a look what else we can do here. We can change the scale of our geometry. Let's just have a look at the scale parameters. You can sync this by time or lifespan. You can have them grow over time or born at a certain size and they kind of fade. They fade.